Next presentation is going to be from Frederick Francois Chesneau. He is going to be talking about automation. And so Frederick is the head of laboratory data solutions for the digital lab at BASF Digital Solutions. And after leading material research labs for 5 years, Frederick has been driving digitalization at BASF for the past 7, currently leading a global team of 15 developers focusing on software for the lab, from experiment planning to laboratory automation systems. And so, as I mentioned, he's going to be speaking to us about automation, new frontier for Allotrope, walking through some of proof of the concept implementations that he and his group have been doing with ASM's, Allotrope Simple Models, to provide standardized data for synthesis workloads at BASF.
Thanks everybody. Thanks for having me today. Very happy to talk to you about what the work that we've been doing with Allotrope at BASF. And this all started for us when we were looking again at data standards. I wanted to have a really deep look into the standards, and having done that, we've of course stumbled across Allotrope. And what I'm going to be talking about today is not Allotrope in general, but rather the ASMs, which we've been working with extensively. Why the ASMs? In the course of that project, what happened was that the foundation released also the ASMs on a set of Creative Commons licenses, which then opened for us a lot of possibilities internally. So similarly to what was shown by Maxime earlier today. And so the focus of the talk today is not so much the traditional uses in analytics, which we definitely have and we're excited about doing that also with Allotrope internally, but we're really looking at some automation use cases. So let's dive in. So why do we think that Allotrope would be a good format for automation? Well, first off, you have the ontologies, right? The ontologies for us are critical. They give us a standardized vocabulary out of the box. We do not need to think too much about this. We can integrate them internally, and that allows us later on to also more easily bring all data together, independent of the system they've been produced with. Yeah, so a measurement time is always the same definition. Is always a measurement time, for instance. Yeah, so all these things, that was a critical point. The second point is that the ASMs themselves are really easy to use. They're based on JSON. They can be handled with standard tooling, and can be validated and are, according to the license, to some extent at least extensible. And those parts are really critical for us. Then we looked at the data models available, and from the looks of it, I'll be a bit bold and say that up to 80% of the models, we have models to cover about 80% of our needs, more that way, and which is great. Yeah, so I mean we're already a lot of the way there. And finally, new models from our experience. So having really looked into this, new models are actually quite simple to create and can be created really quickly. So, and thanks to Benjamin and everybody then for helping us out with the models I'm going to be presenting today. That was really great to work with you guys, and that really emphasized the quickly point. Yeah, so we did all that work really fast. So that was a benefit. And the fourth point for us is the community, right? The community bring that experience in and really being able to share and make things better for ourselves, but also for the community. Yeah? And that's a very key aspect here of the whole endeavor. Yeah, and of course profiting from the expertise of the data modeling group. So what's our use case for today? So the use case, we have a lot of labs. Maybe you have a similar use cases where we do synthesis. And in a lot of those laboratories, we do not necessarily want to do automation in the sense that you would say, okay, now open valve A and then close valve B and insert so many milliliters of that solution and so on and so forth. Rather, colleagues really want to start the reaction and then monitor it. So more along the lines of IoT, yeah. And we've developed solutions internally to do just that, to capture the sensor data. So you see in the middle part the such a dashboard that we have. And so our sensors then they produce data over hours, days, or even weeks. Yeah. So it can be that this reaction runs for a few days, can be that it runs for a few weeks, and we want to kind of really capture the whole data set from start to finish. Yeah. And those data are logically put together on the first level by the experimental setup. Yeah. So the set of sensors that we have is really specific and unique to that experimental setup, and can be reused and is reused basically throughout different experiments. Yeah. And typically, what you want to do with those data afterwards is nothing different than what a lot of us do. Yeah, we want to visualize them, want to integrate them with other data sources, want to perform analytics on them. And for us, having looked at this, I think for us the key enabler of doing something like this is a standardized data format, and in our case, TASM. Yeah. And so, to prove that, we did then the proof of concept using 4 of the 4 models that we contributed into the modeling group. The model with a peak sensor, monitoring pressure, stirring, and monitoring temperature. Yeah, so those models are are basically ways of representing time series of the various quantities. Yeah, so temperature over time, steering over time. So all of those 4 models have this time component added to them. And the way we implemented this, we had to implement 2 things. First, we had to implement in our case, a Python package, which has a collection of basic fields. Yeah, so such as the sample identifier, say measurement time is one thing as well, and so on and so forth. And based on that, we've implemented then the various models. So we've implemented, I think in total, implemented 6 models, but for the purpose of today, we'll show just the 4. And for those of you that are a bit more in the Python space, we used Pydantic to base those models on, and that gives us 2 very good things. First of all, we have out of the box data validation already beforehand. And Pydantic also contains a tool, and that's actually a pretty cool thing that can enable us to translate the JSON schemas into actual Python code that we can then use directly. Works really well for simple models. For more complex models, it's a bit more finicky, but overall, based on those technologies, then we've been able to really quickly iterate and create models. And the second thing that we did to do the proof of concept is we then went on and created an API with an endpoint that can deliver standardized data for us, as well as an endpoint to validate the model instances. I will show you both of those then later on. In terms of time, how long does this take? Yeah, I think in our case, we had a single developer that worked on this for about 2 weeks. And that's it. That's the whole time that we needed to implement then this use case. So let me do something that you can never do. I will then attempt a live demo for you, and let's see if that works. So it worked 10 minutes ago, so I hope that it will work still today, right now. All right, so let me share my screen again. I think I have to share this one, yes. Okay, I have to do it differently like this. All right, so let's start with a typical, let's say CSV part. So the tool that I showed you before collects the data, yeah, of course in the database, but also spits out that data in a CSV format. So you could say, okay, now I want to take my CSV data and transform it into Allotrope. Yeah, so the data looks something like this, where you have different times, different columns for the different sensors, and very nice, yeah, very structured. However, you're missing a bit of information, and that can be alleviated then with the ASMs, yeah. But that's the data, yeah. So you see different things. So now if I then take that data, which is here, and pass it to this function that we created, which passes a CSV file with multiple columns. And now I will attempt this. I will click on this, and you will see that here we should create a file, hopefully. Yes, that is created here. And now if you allow me to format the document, you will see the data from the CSV file in a beautifully crafted then series of ASM documents. So if you look, the way we structured this, because I'll come to that later. That's one of the limitations that we want to talk about. So if you look now at this, let's say this column, we had it here. So that would be this column here. It then is its own document, yeah, its own Allotrope data model instance, and you find it then everything here with experimental identifier, the measurement, the data cube, with all the data contained into it, with also the device then document as well, that then gives us the identifier of the device on top. Yeah. All right. So this is the case if you have then a CSV file. Now, as I said, the tool that we use to collect data has its own database. Always okay. Let's now go directly to the database, and let's get that data, right? So why not? Why having to go across over a CSV file? So let's do this right now. So you see we have here. I'm going to request now running for now on my computer. I'm going to call this endpoint. Let me show you the endpoints briefly. They are here. So we're talking about those two. This data standardized here, and we have also the validation endpoint that will show you. So now I'm going to try and get the data from that experiment, and I'm telling it, okay, give me everything. Yeah. So we could limit this to how many data points we want, but for now, we'll say, okay, just give me everything. And let's try this. So let me close that. And so we should see now here a couple of data also appearing. Some file appearing somewhat. It's running. It's taking a bit longer. It's going to a database. And you see here now my new data appeared. And let me reformat this. And I have exactly now the same thing. Same format. All right. So if we compare those two, if we compare this with our previous data, the order is a bit changed, but you will see that you find every single item in that data as well. So exactly the same thing as with the CSV file. Yeah. And now to finish this off, we say, okay, now that's nice, but we want to be sure that the data works. Yeah. So we will now do this. We are gonna take a data that I've prepared before. So this contains the list of the models that we want to validate against, as well as the data itself. Yeah. So if you see, that's the same data then as before. And now I've specified which models we want to validate against. Let's go with this. Yeah. And if I do this, then you see that I receive then the data that tells me, yes, every single data model instance that I have in this file is correct, yeah, and is conforming to the Allotrope, the corresponding Allotrope simple model. So amazing, we went through this successfully. So let's Very nice. So now let's, just to finish, I hope I've shown you with this that Allotrope really is for us a promising data standard for use in automation workloads, right? And why? Because it does a few things well right now. Just from the point of view of right now, it's simple to implement. Yeah. I mean, a couple of weeks is nothing. It has quite quickly developed models for it. So we actually, before we received our models, we actually implemented them ourselves, yeah, without having the JSON data models before. So it can be very quick to iterate, and it's like very well suited, not just to present data, but also to facilitate its uses in downstream workloads. Yeah, just to give you an idea, having presented this internally, say, look, you can do it this way with the API endpoint, and this is the data you get. The response I'm getting is, wow, that's amazing. That's a dream. Yeah. So I think there's a lot here to like about the ASMs. During our evaluation, we found some gaps. Yeah. So we found that there's no real concept of experiment so far that we could see, which means that each sensor or instrument is independent right now, but that's okay. Which leads then to some metadata redundancy in the automation use cases. Yeah. Could lead to that. The concept of the workflow, meaning which step comes after which one, is not formalized, at least here. And the investigating then all the models, we found also that the structure of the older new models differ a little bit, so that could create in the future some issues with when trying to parse the data and so on and so forth. And then we had some questions. So having presented the results internally, then I got a few questions back. So I've put 3 here to start the discussion for tomorrow. The first one that came was, okay, great to have different versions of models, but are the newer versions backward compatible? So are we going to run into issues later on down the line? How do we handle then different precision levels in different parts of the measurement? Is there something like this also in Allotrope? And how do we handle then the measurements that are done in one unit, but that unit is different from that of the model? Or can we use also a factor maybe to deal with things like this, with things like milliliters, liters, and so on? So this is where we're at. I think, again, for us, the same thing as what Azadine was saying earlier, and what Diego was saying earlier. I think this should be standard, should be implemented from every manufacturer. We're doing it for our own solutions internally. We can do it, no problem. But at the end of the day, we also need then the standardization to be done on the instrument manufacturer side, so that we can just do what we do best, which is integrate the data with the different sources that we have internally. With that, I want to thank you and looking forward to your questions.
Thanks,